Park Tools, one of the most iconic and recognizable names in the world of bike and workshop tools. But what's the story behind this iconic brand, and who are the people responsible for turning it from a small-time bike repair shop in the 1960s to a multi-million-dollar, internationally recognized tool manufacturer? Well, I'm here at their HQ in St. Paul, Minnesota to find out, and I'm going to go behind the scenes to find out how their tools are developed, tested and manufactured before being shipped to customers and bike shops around the world. Park Tools have got over 500 different products in their lineup, and it all started with this, the PRS-1, the Park Tools repair stand, first generation. Now, this prototype was made using old kitchen sink, an old truck axle, an old bike hub, and even parts of a hockey stick. Now, it's developed by Howard Hawkins, father of current Park Tools president Eric Hawkins, alongside Art Engstrom and Jim Johnson, because at the time, no such product existed. And when you had to repair a bike, well, it was simply a case of flipping it upside down and crouching down on the floor to repair it. Far more goes into it than you would ever imagine. Eric Hawkins is going to show me the inner workings here at the HQ, and I'm told it all starts with an idea, right here in the design office.
So this is our engineering department. The ideas don't necessarily start here. They start with our team that goes out to the world and says, here's what we think we need to make, or we get ideas from people. But then the next step is it comes here, and we figure out how to make it work, putting together assemblies or designing certain parts, but everything we make starts here in the engineering department. We use SolidWorks, which is an engineering software, and we can make a whole assembly. We can do simulation testing on it. After this stage, then we build a prototype, and then we'll use the prototype. We'll send it out to local shops, on the QT. Yeah. And then that feedback comes back to here, and then to the rest of the people on our engineering team. And the product continues to progress after that. So once we have a design and we're prototyping and so on, then it kind of heads to the engineer's workshop in here.
Wow, this looks cool in here.
Yeah, so we do a lot of different things in here. We do some quality testing, we do some prototyping, assembly. Right now we're doing some longevity tests. So this is a brand new stand that we're coming out with, and it's a stand that lifts the bike off the ground, but it's not powered. We've powered it here just for testing, but we include a hand crank, or you can put a drill on it to make it go up and down.
So this is just going up and down all day long with all maximum capacity on it?
Yeah, it's got about 55 kilos on it.
Yeah.
And it's just gonna keep going up and down. And as long as we're here, we just turn it on, it goes up and down, and it'll probably do this for 3 or 4 weeks.
And what is this machine with the silhouette I can see?
That is called an optical comparator. We're basically looking at a blown up version of things. We can put measurements on this. We can compare one part to another. But what this is showing, right here, you see that's the tip of the thread.
Yeah.
All right? But you see the other one?
It doesn't look anywhere near as sharp.
No. So we discovered this from one of our suppliers, and now we have to test each one because they didn't make them all like that.
So issues like this that you can spot are going to be relating to the strength of the thread.
Right,
how long
and how well it engages into the crank.
Wow.
Because that's for the crank puller.
Okay, so this is where we're looking at stuff before we're seeing the sort of production runs of stuff.
Right, no production happens in here.
This is all design testing way early on in the process.
Right.
So then when we head outside, that's when we start to see production.
That's where we make the stuff.
Okay, let's do it. You lead the way.
All right. Yeah, where do you start? I would describe what we do as light manufacturing. We do a lot of assembly. We do a lot of machine work. So we have CNC lathes and mills, a lot of welding. We're putting holes in things and tapping and so on, laser engraving, and then some real specialty machines that we use that probably nobody else would use because they are related directly to the tools that we make.
Okay.
But what you see right in front of you is the assembly area. And these guys move around depending on the job. They may be all week at one job, or they may be 2 hours, and they may work by themselves or in teams. Our line is made up of about 3,000 different parts.
Yeah.
We don't make them all here. We make the majority of them in the state of Minnesota. We do import some things because you have to, but we use local suppliers, stampers, injection molding, plating, powder coating, heat treating, tumbling, all that. And then as part of that, we do our own laser engraving, and that'll act as a part identifier. We have a lot of drifts and things that go in a set, and you have to have part numbers on those.
So all of the parts laser engraved with, like you say, the part numbers, which have got some interesting codes to them as well, and all the logos.
Yep.
But having the ability to control a lot of this stuff in-house is fantastic.
Yeah.
But it also means we can have some fun stuff as well.
Yeah.
So we can get, like, my name on some parts like this.
Right.
That's really cool. Do it.
Almost always have somebody assembling and calibrating truing stands.
Yeah.
This is the TS 2.3.
Okay, so that's an interesting point you say about the names, actually, because a lot of every single tool has got its own unique code.
Right.
So how does the coding work? Because to most people it might seem confusing, but it's got a really set form.
Well, the TS2, it goes way back to the early 70s, and it just means truing stand.
Easy.
Right, and the TS, we had a TS1, then we had a TS2, and now we've had 2 different kind of upgraded versions over the TS2.
Yeah.
So the first time we made it taller, we started getting 29ers and so on, and then we made it, we changed how, we used to chrome plate this whole thing. But because of one reason or another, we're trying to get away from chrome plating. So this is all powder coated. So therefore it made it in the TS 2.3.
Okay, so the first bit is the model variant, and the second point is the upgrade or version of it.
Right.
Oh, it sounds so simple when you explain it like that.
Sure.
All right, so you're gonna need to earn that laser etching on that multi-tool.
Fantastic.
So we've got some work here to do. TM1s. See, this is the perfect time for you to do this.
TM1, tension meter, 1.
Correct. Nail on the head. So TM1, you're gonna get to use this a lot when you're tensioning your wheels. These are calibrated tools. They need to be calibrated to the spokes that they're gonna use, and a lot of spokes are different dimensions.
Yeah.
So we need a set spoke with a set calibration that we know to kind of base everything else off of.
So this has got big weights hanging off it underneath. So we've got a set, we know what this machine and this piece is measured at.
Yep.
We need to make sure this relates to the right reading.
Exactly.
Okay.
So this has 120 kilograms hanging on it, so it's an absolute 120 kilograms. When you put this on there, it's gonna actually be a little bit different.
Right.
But, so you'll see in the middle on the top, the pointer is pointing towards 23.
Yeah.
We want it to be at 25.
So this needs adjusting.
It needs adjusting. So to move that up, we need to increase or decrease the amount of spring tension. So we are going to turn that out a few turns.
Yeah.
So,
Oh, that's really close now.
yeah. So and then depending on how you let it go, it lands right on it. But you want it pretty consistent. I'm gonna say that one's good. There's gotta be a tolerance for everything.
Yeah, yeah.
We're not 1 off. We're like a half a millimeter or less off. So that one's good to go.
On
So
my
once-
limited knowledge, I'd say that's good.
that's good to go.
Okay, right, so in here, release,
Yep.
just gradually a couple of times, let it settle.
Yep.
So we're at 23.
Yep. It's almost the same situation that I had.
So, right, flip it over.
Yep.
On this bit, take the spring tension off,
Yep.
and then, whoa, back it off.
Yep.
I've gone one whole turn.
Yep. And so
Right.
and then you'll see what
Cycle
happens. Yep.
I mean, that is spot on 25. You cast a good eye over
Oh,
that.
man.
Am I hired?
You're really good at this. You're
hired.
good. Yeah, you're going to be here for a long time.
So, a few hundred more to go.
Yeah, a few hundred more.
We're not finished. The wicking thread.
Wick and thread.
So this is on this part here.
Yep, right on that. Because you can see the end of the bolt there. That's the bolt that's going through the whole thing.
How to squeeze the trigger.
Yep, just a little bit. You don't want a ton on there.
I mean,
so,
you know what they say, once you've done one, you've done them all. So I think, should we bow out gracefully on this?
Yeah, I think that's probably the best idea.
This looks like a whole bunch of bike chains.
And it is.
What are you doing with bike chains?
We use bike chain on our chain whips, and we make 5 different chain whips.
Okay.
So this machine starts with a roll back here of, I think it's 11-speed or it's 12-speed chain.
Yeah.
Because that'll fit everything.
Of course.
Any derailleur type setup. And then this machine runs it through and it cuts it off in short sections and long sections.
No way.
Yeah. Otherwise, we're sitting on a press and counting or gauging and pushing the pin out.
And actually, talking of the pins, this is what is pushing the rivets down together, yeah?
Yep. So this is the machine we use to finish off the chain whips. So basically it goes in here, you put the chain on, and then a pin comes from the bin, comes through the tube, goes right down, and it rivets on.
The thing that I can hear whirring around in the background, is that one of the lathes?
That is one of the CNC lathes, yeah.
Okay, so let's head over there and explain to us what's happening over in that station, because I can see so many cool bits of machinery.
Yep. All right.
Okay, so this is what I could hear in the distance whirring up to speed.
Right.
So there's what, 1, 2, 3, 4,
4 of these.
4 of these machines.
Yep.
What's this one doing?
This one is making bottom bracket tools.
Oh, yeah.
This particular one is for the T47.
So this is coming straight out of the machine, and then that's obviously going to need to be checked for sizing.
Check for sizing, and then we actually will put a little chamfer on there so it's easier to put the ratchet tool in.
And then it
And we
needs
do
to
that
be...
by hand.
Oh, okay. Then this will need to be anodized and laser etched.
Laser etched, and then packaged.
Okay.
So this is one of the things where we buy these bars and we make the tool,
And then this comes along on a little conveyor belt.
and we can do either steel or aluminum on these machines. Obviously, aluminum machine's faster.
Yeah, because it's softer material.
There's softer material.
Yeah. Now, this is one of the coolest things I think I can see so far. Correct me if I'm wrong, but it's a robot welder.
Robot welder. We have 2 of them. They're MIG welders. And so we use them for steel.
Yeah.
And our volume is high enough where over the years we started out hand welding everything. And then now we're to the point where we hand weld a few things, but most everything we put on the robots.
So what is this set up for at the moment?
This is a clamp. We call it a C-clamp. So it's our original clamp that we've made for 50 years. We don't sell very many of them anymore because we have a micro adjust clamp that's a different kind of casting. But basically he's welding we call it a donut on there, and that's what turns inside the top tube on the professional stands.
Okay. It's so cool seeing that spin round. But you guys are still welding stuff by hand as well here?
We do. We weld a few things by hand. Mostly the bigger things, I'll get him to weld here because he's going to spin that. This is the lower base support for our single and double arm professional stands that you see in all the bike shops. And they share the same bottom part. So he's taking a tube that we have milled a window in.
Yeah.
And putting a block in there. That's where the lock blocks go in. And then he's welding that in, and he's welding a base onto the bottom.
And this has got the piece which rotates the tube around so that the welder hasn't got to move himself around.
Correct.
That's cool.
Leaving the welding department.
Yeah.
And now we're going to get into more storage.
There's so much like height and scale to everything here.
Yeah, isn't that crazy?
Yeah. So all of this is parts ready to go.
On your left, these are all finished products ready to be picked.
Yeah.
And we mostly ship our products, we'll get to the shipping department in bigger shipments to distributors.
Yeah, that makes sense.
And then in here, we had planned to add on to the building right when COVID started. And we got to the point where we had to make a decision, are we gonna move forward or are we gonna pause?
Yeah.
And we moved forward, and it was a good thing we did, because COVID, it was nuts around here.
Yeah.
We couldn't make stuff fast enough. And so we needed all this space.
Yeah. So this is like its own little assembly line contained within itself. So what is it that's happening here?
This is for our electric lift stand, PRS 33.2.
Wow.
Yeah.
A long way from the original, the PRS-1 that I saw earlier.
A long way. So it's an electric lift stand that mostly it's shops that are working on e-bikes.
Yeah.
But you can obviously use it for any kind of bike. Not really a consumer product, but we sell these all over the world. We sell them in 6 different electrical configurations.
Yeah.
And it'll lift 55 kilograms. And we're working on the next version that'll lift more.
Yeah. Well, I guess that's the thing with e-bikes being more popular and cargo bikes.
Yeah.
Difficulty of cargo bikes is how do you pick these things up?
Right.
They're so massive on the scale of them. So, yeah.
And we're spending a lot of time on that right now, too.
So that's some of the headaches and problems that the design office have got to try and fix.
But I'll tell you a really fun thing about our business. We're never the bad guy,
Yeah.
right? If they come out with a new bottom bracket standard, we make the tool for it.
Yeah, you're just solving.
We're not the bad guy.
You're literally problem solvers.
Right. So it's an opportunity for us. And the same with the heavy bikes. Remember, for years and years, they're trying to make bikes lighter. Now they're getting heavier and harder to pick up.
It's like gone full circle.
Yeah.
Okay,
That's
so this
okay
is,
with us.
So this is more of stock packaging ready to ship out.
Yep.
So I guess we should probably look at the next stage of once you've got some finished products.
Yep.
How do they get packaged, like boxed up, ready to sort of leave this place?
Sure.
Yeah.
Let's do it.
But this is right into the heart of packaging.
This is packaging. So this has become more complicated over the years. We still do a fair amount of blister packaging,
Yeah.
mostly because it's fast and it protects the product, and some of them are small. But we are also experimenting with new ways to make our packaging greener and more recyclable.
Well, that's a good thing.
It's a good thing. We make things in every shape and size. So there's no one way that can work for everything.
So these machines are set up almost in the same way as some of the CNC machines to be really versatile to do different jobs.
Yes.
So what are the inserts that we can see on the bed?
The inserts are nesting trays, and that is the shape of the blister for each tool. And you can see right over here, those are all nesting trays for different things that we...
And there must be like 200.
Yeah, but it takes 8 of those for each tool. And then like a spoke wrench, we make in 6 colors, but it only gets 1 of those boards, right? Or 8 of those boards.
Yeah.
But
So you got to get the right card insert with the right piece there to go on there, and the right plastic insert, and the right tool, and put it all together.
And the right heat and the right speed and all that kind of stuff. Other than that, we put things in boxes here. We make kits here, so we make a lot of different tool kits. We do some final assembly here.
Yeah.
And then bag kits, things like that, small parts, that all comes through this department.
And then ready to get shipped out.
Ready to get shipped out.
That's absolutely crazy. While having premium tools is a smart choice for home mechanics, it's more of a necessity for professional ones. And professional teams around the world are often found using Park tools. And it's a fairly safe bet to say that you could go into any bike shop and find some Park tools. But more important than anything is knowledge. And up here is where the legends Calvin and Truman teach the world how to fix their bikes.
Let's go check out where we teach. So this is where Calvin and this is where we shoot. This is also where we kind of hang out and do a lot of scripting, because it's quiet, easy to think up here. And then you can sit and do stuff, you're not being bothered, and you can walk through all the different processes, which you walk without a bunch of people like looking in your office at you like you're strange because you're sitting there talking to yourself, walking through a script.
So this is like the studio that we have at GCN as well.
Yep.
And you guys are kitted out with every possible thing that you can have.
Yeah, so we try to have everything as up to date as possible on this wall. We try not to do too much heavy working with these tools just to keep them in pretty good condition. But every once in a while, you know, we need a tool and we'll come up here and nab one and bring it down and forget to put it back. So, but every tool should be here. And we do work up here. So all the bikes that we really like having live props. It's a really important thing to us to give people a real example of the issue that they're facing so that people aren't like, well, my example, the tire just fell right off. So we go out and we spend a lot of time trying to find tires that are stuck or seized on there, or the seat post video, extracting seat posts. It took a long time to actually find a bunch of seat posts that were seized, and so it was fun.
And so this is the place where Ollie and I have had video calls with you and Calvin. That's kind of crazy to think that, like, I'm now on the complete other side of the world in the same spot. So there you go. That is my time at Park Tools drawn to a close. I tell you what, it's been absolutely brilliant to see how everything is made from start to finish, meet all the people behind the scenes, and most importantly of all, be able to show you guys at home what on earth actually happens here. If you have enjoyed this video, please do give it a big thumbs up. Get involved with the comments section down below. Share your thoughts on the entire process. And of course, if you have enjoyed it and want to help support our channel, share this video far and wide for all your friends to see, and hit that subscribe button and turn on your notifications. Right, I'm out of here with a brand new multi-tool. See you later.